Hello and welcome to this lesson about absolute value inequalities. The learning target for this video is solving and graphing absolute value inequalities. So let's start by thinking about some of the differences between equations and inequalities. So we're going to make a little table here. Let's go equations on this side and inequalities on that side. All right, so with equations, we have one solution, more often than not. Inequalities, we now have a range of solutions. In other words, where we have many solutions instead of just one solution. So for example, think of x is less than 1 and compare that to x is equal to 1. X equals 1 has one solution, 1. X less than 1, well, we have a ton of options for that. We could use 0, we could use -1, we could go -3, we could go -11, we can go -222. We have a ton of options, and we've only dealt with integers. We didn't even think about, fractions and decimals and all that other stuff. So that's one of the differences. The other difference I want to highlight really quickly is the difference to approaching it. You don't have to be careful when you go, like maybe x plus 1 is equal to 2, and then you go, hey, 2 is equal to x plus 1. We can flip between these two very easily. However, we do need to be very careful between going x plus 1 is less than 2, and then we have to make sure it's 2 is greater than x plus 1. All right, so we have to be careful here, because there's that one extra rule that whenever we're multiplying or dividing by a negative, we flip the inequality. Let's actually see that in one more color. Multiply, divide by a negative, we flip, there we go, the inequality. Oops, there we go. Try one more time. Inequality, there we go. All right, so flip the inequality. So remember, there's that one extra rule that you don't necessarily get when you're solving equations. And so we have to keep this in our mind as we are working with absolute value inequalities. So let's take a look at some examples. So the first one, let's go the absolute value of 2x minus 7 is less than or equal to 15. All right, so when we're dealing with absolute value equations, we break it into two separate equations, and that process is going to remain the same for absolute value inequalities. 2x minus 7 less than or equal to 15 will be the first one. But now we have to be mindful of the inequality sign. Now, when we were doing equations, I said, hey, just put a negative sign on it and you're good to go. That's okay for equations, but technically what we're doing is we're dividing by -1. So when we write that second inequality, 2x minus 7, we're going to have -15, but instead of being less than or equal to, it's going to be greater than or equal to. So make sure that you flip one inequality when you are setting up the absolute value, or the two inequalities from breaking down your absolute value. Then it's business as usual. Add 7 to both sides. 2x is less than or equal to 22. X is less than or equal to 11. Add 7 to both sides. 2x is greater than or equal to -8. Divide by 2. X is greater than or equal to -4. And if we wanted to, we could graph these. So on a number line, we end up getting a compound inequality. And so that's the other thing that's going to happen with absolute value inequalities, is that they're always going to be compound inequalities, which is why we talk about compound inequalities before dealing with these. And so just make sure that you have them in the proper order, so -4 and 11, and then graph according to its parameters. Here, we're going to be using closed circles, and we're going to go to the right there, we're going to go to the left here. So this way, and they're going to be bounded together like that. All right. In fact, anytime, and we'll talk about this in a second, anytime you see a less than, it's going to be a bounded graph for the compound inequality. To prove that to you, or not really necessarily prove it to you, but let's give you another example. Let's say we have the absolute value of x plus 4 is greater than 15. Okay, so here we break it into two separate inequalities, just like we did before. We'll get x plus 4 is greater than 15. That first one is always as is without the absolute value bars. Second one, x plus 4, negative 15, but we have to change the inequality to less than. Subtract 4 from both sides, subtract 4 from both sides, and we'll have x is greater than 11, x is less than negative 19. Now, notice our first one was less than or equal to. This one is greater than. And if we take a look at the graph, we put the numbers on there, negative 19 and 11, we're now going to have an or inequality because we're going to be greater than 11, but less than negative 19. And so, what we can take from this is a neat little table. Less than or equal to is essentially going to be an and inequality. And that is where it is going to be bounded. So it's going to look like that. On the other side, you have greater than or equal to. That's going to be an or inequality. And that's going to have a gap. Just like that. Now, would like to also point out that if I wanted to, or if anyone wanted to, they could make these inequalities fairly complicated with a lot of sign flipping. So we'll do one more example. Let's say we had something like the absolute value of negative 4x minus 1 is less than positive 2. Actually, let's make that a slightly bigger number. Let's go 7. Okay, so I rewrite my two inequalities. I will get negative 4x minus 1 is less than 7. Negative 4x minus 1 is greater than negative 7. But notice how I have negative 4's here. Eventually, I'm going to have to flip the inequality all over again. So that is a possibility, just to throw that out there. So could add 1 to both sides. We'll have negative 4x is less than 8. So x is greater than negative 2 when you divide by negative 4. Or add 1 to both sides. Negative 4x is greater than 6. So x is less than 3 over 2 of the negative kind when you divide by negative 4 and reduce. And then when we go to graph it, we're going to be negative 3 over 2, negative 2, open circles, bounded, like that. So you just have to be very mindful and be very careful as you're going through this. This is where I wanted to talk about that whole thing about less than and less than or equal to is the and then greater than or equal to is the or. Whoops, did that on the other slide. Oh well, special cases. Just like absolute value inequality or equations, you could have no solution, but you can also have all real numbers. So, for example, let's say we had absolute value of 2x plus 1 is less than or equal to negative 5. Well, we've talked about this before. This is a distance. Distance can't be negative. So, there is no solution here. And again, you have to be careful to make sure that the absolute value is isolated and it is less than a negative number. Because if we take the same pieces, 2x plus 1, absolute value of that, but now we say it's greater than negative 5, well, guess what? Same idea applies. That's a distance. It can't be negative. It will always be positive, meaning it is always greater than 0. So guess what? All real numbers. You can plug whatever you want into x and you will always get a solution. So there are some special cases with absolute values. So this is absolute value inequalities in a nutshell. Good luck with your homework and practice, and let me know if you have any questions.